Next, we want to look at evaluating some logarithmic statements. We'll start off with a few simpler examples and work our way up to example 13, where we need to use the properties we established in this section to first manipulate the expression before we can evaluate it directly. Before we get into any of that, though, we want to just, again, reinforce this relationship between logarithmic and exponential equations. So the log base b of a is equal to c if and only if we take that base b, raise it to the exponent on the opposite side of the equal sign is equal to a, whatever we were originally taking the exponent of. So we want to think about being able to move back and forth between those two notations and understand that those are equivalent statements, even though, again, logarithms can be a little confusing or intimidating, maybe not seem terribly intuitive. Using that idea, we want to evaluate each of the following expressions. Here we have the log base 2 of 4. What we don't know is what that's equal to. In order to determine that, we'll take this log expression and rewrite it as an rewrite this log equation as an exponential equation, and then determine what value we should plug in to make this a true statement. We have 2 raised to some power must be equal to 4. Well, in order to get 4, we have to square 2, so x must be 2. That tells us that the log base 2 of 4 is equal to 2. Similarly, in example 11, log base 7 of 7, if we don't know what that's equal to, we can rewrite this as an exponential equation where we get 7 to the x power is equal to 7. In order for that to be true, we must have x equal to 1 because anything raised to the first power is itself. So the log base 7 of 7 is equal to 1. In example 12, we have the log base 3 of 1. Rewriting that again as an exponential equation would give us 3 to the x power is equal to 1. The way to get 1 is to take any number raised to the 0 power, so x has to be equal to 0. That tells us that the log base 3 of 1 is going to be equal to 0. Also, for examples 11 and 12, we could have used those first 2 properties that we established back at the beginning of this section. But if those don't ring a bell in your brain initially, you can always just take the step of converting to an exponential equation. In our last example, we want to do the same thing, but now we have a more complicated expression. In order to evaluate this logarithm, we have to condense it down to a single log statement. And the first thing that we want to do in a case like this is get rid of any coefficients. So first, we'll rewrite this as the log base 2 of 1/4 minus the log base 2 of 2 to the 3rd power. 2 to the 3rd power is just 8. And actually, I misspoke a moment ago. We don't have to condense this down to a single logarithm. We need to just bring that coefficient up as an exponent, and then we can evaluate each logarithm on its own. We could also combine them, but I think in this case it's a little easier to take it a piece at a time. So this first logarithm means we need to solve 2 to some unknown power, needs to be equal to 1/4. And for the other one, we need 2 raised to some unknown power, needs to equal 8. That second logarithm is probably the easier one to evaluate. 2 to the 3rd power would give us 8, so we would get y equals 3 there. To figure out what our value is for x, that gets a little bit trickier, but we know that in order to make 2 of 4, we'd have to square it. But in order for that 4 to move down to the denominator, that exponent would have to be negative. So in this case, x would have to be negative 2. Because 2 to the negative 2 power would be the same thing as 1 over 2 squared, which would be 1/4. That means we can go back and substitute our log statements out with these simplified answers. The log base 2 of 1/4 would be negative 2. And then the log base 2 of 8 would be 3. So to get our final answer, we would take negative 2 minus 3 to get negative 5.